So I try to point out each week which videos are like the most important. I think they're all important, but in terms of where the focus of our attention lies is this video and the next video. So solving exponential equations and solving logarithmic equations. So essentially they're sort of culminating topics because we spent a lot of time last week developing strategies for how do we simplify. We talked about how to expand or condense this week, and now we're just going to put it all together so that we can solve exponential equations. So I've sort of broken it down for you into different methods or different types of questions that you might see, and typically I try to put them in order from least difficult to most difficult, or least amount of work to most. So method one, my favorite, because both sides, obviously these are exponential, both sides already have the same base. And so all I would have to do on each side is use that basic property that says, hey, if I take the log base 2 of 2 to the x minus 2, and if I take the log base 2 of 2 to the 4x plus 7, remember that property that says if you're taking log base 2 of 2, those things are essentially 1, and then I'm popping this to the front, and again this is going to turn into 1, and I'm popping this to the front. So that means what I'm going to be left with is these guys are gone, and I have x minus 2 equals 4x plus 7. And I feel very confident that from this point you can solve very easily. I would take each side and subtract 1x. And again, I'm only showing one step per line of work. I would take each side and subtract 7, so I'd get negative 9 equals 3x. And then I would divide each side by 3 to get x equals negative 3. And keep in mind, you can always plug that value in and check. So does 2 to the negative 3 minus 2 equal 2 to the 4 times negative 3 plus 7? Well, negative 3 minus 2 is negative 5. 4 times 3 is 12, negative 12 plus 7, which is negative 5, and those two things are equal to one another. So feel free to do the check. I'm not going to do any more checks just for the sake of time, but you can certainly do that. Each of these pages I have a try one, so instead of having a whole different slide with a question for you, this is where you would pause, try the question, then press play to check your work. So again, I would take the log base 3, and again I'm choosing base 3 because that's my base. Log base 3 of 3 to the 2x plus 1 equals log base 3 of 3 to the 5x minus 5. These guys cancel, that gives me 2x plus 1. These guys gives me 5x minus 5 because I'm essentially moving these guys to the front, which are my exponents. And now it's a simple equation to solve. Let's subtract 2x from each side, add 5 to each side, divide by 3 to get 2, and my answer is 2. Method 2 is like method 1. Some of you won't like it because you don't like dealing with exponents, but unfortunately it's a fact of life. What will happen here is I know that I can write 8 as 2 to the third, 2 times 2 times 2. And I know I can write 4 as 2 squared. So that's what I'm going to do is I'm just going to rewrite 8 as 2 to the third, and then still to the 2x. I'm going to write 4 as 2 squared, and still to the 4x plus 7. So what does that do for me? Well, I've got 2 to the 6x, and I have 2 to the 8x plus 14. Now does it look like what we did on our last example? Yes. I can take log base 2 of 2 to the 6x and log base 2 of 2 to the 8x plus 14. So these guys cancel, I get 6x. These guys are 1, I get 8x plus 14. And now it's easy to solve. Subtract 8x from each side, divide by negative 2, and I'm done. So the next question obviously is the same idea, but notice I've given you a fraction So don't freak out because we have to just get used to dealing with these. When you have a fraction, I'm trying to write 3 to what power is 1/9. So I know 3 squared would be 9. To make it a reciprocal, I just do negatives. This is going to be 3 to the negative 2. So this is 3 to the negative 2 x, and 27 is 3 times 3 times 3. So that's going to be 3 cubed to the x minus 1. Then I simplify. 2 times x is negative 2x. 3 times x is 3x. 3 times minus 1 is minus 3. So what's going to happen? I'm going to take log base 3 of each side, because that's going to be what cancels out the 3, which is the base of my exponent. And then log base 3 of 3 to the 3x. That's a lot of 3's. Log base 3 of 3 and log base 3 of 3, remember that's just 1. And then I'm using that power rule to push these out front. So that gives me negative 2x equals 3x minus 3. I'm going to subtract 3x from each side. And then I'm going to get x equals, and I'm going to divide each side by 5, 3/5. And again, you can definitely do the checks to make sure that works, and I suggest doing that. Feel free to plug in 3/5 and make sure you get the same answer on each side. So method 3 typically are the worst. The worst meaning this is where you're going to, have to do more work or easier to make a mistake, etc. So as you can see, method 3, I don't have a common base. I can't just take log base 5 or whatever of each side, and actually I can, but it's not going to work out to a nice pretty number. So what I want to do is I want to make sure that, say, whatever is the exponent, whatever term has the exponent on it, is all by itself on one side of the equation. And whatever that base is, just like I did before, I'm going to take the log of that base to each side. So I'm going to take log base 5 of 5 to the x minus 7 and log base 5 of 42. Now log base 5 of 5 to the x minus 7 just gives me x minus 7, as it always does. But on this side, if you'll notice, log base 5 of 42 is going to be like a decimal answer. So notice for now, I'm not turning that into a decimal answer because, again, we don't want to round in the intermediate steps. And sometimes they'll ask for the answer both in exact form and in approximate form. So in exact form, I would never take the log base 5 of 42. From here, remember, I'm trying to get x by itself, so I'm going to add 7 to each side. So if they said, hey, I want you to find the exact form, I'm done. This is the exact form of my solution. Typically, they'll want you to do that, and then they'll want you to find that answer as a decimal. So now I have to get my calculator out, and keep in mind that in order for me, I don't know why things keep disappearing, in order for me to evaluate log base 5 of 42, I have to use the change of base formula that says take the log of 42, divide it by the log of 5, and then take that answer and add 7. So I'm going to take all of that in my calculator. I'm not going to find anything and write down a decimal approximation. I'm going to do all of the work in my calculator now, and I'm going to get an approximate answer of 9.3223. So I've got my real answer, which is this guy. That's my exact answer. And then my approximate answer over here. So I would like for you to try that on the second question, keeping in mind that before I do any of the steps that I did on my question, I would add 5 to each side because I need 7 to the 2x to be by itself. So now I had 7 to the 2x equals 23, and from here is where I would start the process that I did above. So press pause, finish this question, then press play to see how you did. Again, the base is 7. So I'm taking log base 7 of 7 to the 2x, and then log base 7 of 23. This side I'm using the power rule to bring 2x to the outside. Log base 7 of 7 is 1, so 2x times 1 is just 2x. On this side I still have log base 7 of 23. If I want the exact answer, I'm going to take each side divided by 2. That gives me x equals log base 7 of 23 over 2. That would be my exact answer. If they wanted an approximate answer in my calculator, I would first take log of 23 divided by log of 2, and then without rounding I would then divide that by 2, and when I do that I get approximately 0.8057. So again, exact answer versus approximate answer. So we've used 3 different methods. I'm not telling you which method to use on any of these, but press pause, try these questions, then press play to see how you did. So my first one, looking at 125 and 25, these are base 5 numbers. So 5 times 1 is 5. 5 times 2 is 25, so that's 5 squared here. 5 times 3 is 125, but notice this isn't 125, it's 1 over 125. So instead of 5 to the third, I'm going to use 5 to the negative third. So that's how I'm going to start this question, by replacing those values with base 5 numbers. Then I'm going to write 5 to the negative 6x, because I'm going to multiply these two, and 5 to the 2x minus 16. So I could write it as 2 times the quantity of x minus 8, but you might as well distribute. We know from here we have a common base, so I'm taking log base 5 of 5 to the negative 6x, log base 5 of 5 to the 2x minus 16, and I get negative 6x equals 2x minus 16, because those log base 5 of 5s turn into 1s, and our exponents come out front. Now I've got all of my x's to one side if I subtract 2x from each side. So I would get negative 8x equals negative 16, which means x is 2. Again, feel free to plug those back in and check that each side is equal to the other side. Second one, I already have the 3 all by itself, so I don't have to worry about that. But because I can't write 21 as a base 3 number, and don't think, oh, 21 is 3 times 7, so I can write it as 3 to the 7th. That is so wrong that I can't even talk about it. So I have a base of 3. I'm going to do log base 3 of 3 to the x and log base 3 of 21. This side just turns into x. This side is log base 3 of 21. Keep in mind that if it's an exact answer, I'm all done. My approximate answer, I would have to then take log of 21 divided by log of 3, which is that change of base formula. And when I do that, I'm going to end up with about 2.7712. So typically the approximate answer is what they're going to end up asking for, but if they asked for exact, that would be this guy. I know this video is getting a little long, so if you need to press pause and go work in ATLAS for a little while on those questions, you can. I didn't want to leave out what happens when we have the natural exponential equation that contains e. It's really the same process, we're just using the natural log. So here I would subtract 4 from each side and get 2e to the 3x equals 8. And again, I still don't have e by itself, so I would divide by 2. E to the 3x equals 4. And from here is where I would take natural log of e to the 3x equals natural log of 4. So again, see how it's the same process, I'm just using natural log. The 3x is going to come out front. Natural log of e is 1. That's why we can get rid of it. And then natural log of 4. So an exact answer would be the natural log of 4 divided by 3. An approximate answer, I would need my calculator to take the natural log of 4 and divide it by 3, and I would get approximately 0.4621. Same thing for my second one. Remember, I want e to the negative 0.2k by itself, so I would take each side divided by 700. Now, ideally, I would get a nice whole number, but I don't, and so instead of taking 100 divided by 700 and writing down some crazy decimal that keeps going, I'm going to keep it as an exact answer, which is reduced to just 1/7. And on this side I have e to the negative 0.2k. Now, because my base is e, I have to use natural log. So the natural log of 1/7 equals the natural log of e to the negative 0.2k. Remember, this guy is 1, and this comes out front. So I have the natural log of 1/7 equals negative 0.2k. I'm going to divide each side by negative 0.2. And so again, my precise answer looks something like this, which I could write more nicely than that, but I'm not going to, because really on a question like this, they're going to be asking me to find an exact solution. So I'm going to take the natural log of 1/7. I'm going to divide it by 0.2 and make sure I get that negative in there as well. And I would get that k is approximately 9.7296. So once you get the hang of these, they're not so bad. This one's nice and easy, so press pause, try the question, press play to see how you did. And of course, this one, all I have to do is take the natural log of each side, because the natural log of e is 1, so I get x on this side. The precise answer is the natural log of 14.7. The not precise or estimated answer is that x is about 2.6878. Done and done.